Hello YouTube, fellow math students and math teachers, DeVore here again, and today we are going to be talking about solving quadratic equations. Let's make that a capital here, make it fancy, using the quadratic formula. Alright, this one there is a formula, which is quite nice. Let's go ahead and add it in here. That's not what I meant to do. Technical difficulty, hang on. Microsoft Word has it pre-made for me. That way I don't have to type it out. There we go. There is my quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I want to talk about first a specific part of the quadratic formula, and that is this part that is written underneath the radical sign. This has a special name. We call it the discriminant. Let's go ahead and rewrite it clean. B squared minus 4ac. Just a quick reminder, when I use these letters A, B, and C, those come from my quadratic function. The A, B, and C, the coefficients, please make sure that it is fully in standard form before you attempt to use the quadratic formula, or you will be very sad. Just keep that in mind. The discriminant has some very interesting properties. Let's talk about them. If the discriminant is positive, as in the number underneath the square root is positive, we have two real solutions. Now remember what I said about solutions in class and in earlier videos. When I'm talking about solutions, I'm talking about where my parabola crosses the x-axis. In graphing terms, this means that my parabola crosses the x-axis in two spots. If the discriminant is 0, that is, we do all of the stuff and the number under the square root is 0, we have one real solution. Or the parabola only crosses the x-axis once, and this will be at the vertex. It's handy, I suppose. If you've already found the vertex, then you have already found what you need. If the discriminant is negative, that is, the number under our square root is negative. Remember, if that happens, we have imaginary numbers as opposed to real numbers. We have no real solutions. In terms of our graph, this means that our graph never ever crosses the x-axis. Never ever. It just floats out in space. Now that we have that lined up, let's go ahead and do a few examples. Alright, here's my first example. Just your standard run-of-the-mill, why did that pop up, equation. 2x squared minus 4x minus 3 equals 0. The first thing that I like to do is I like to go ahead and calculate my discriminant. It just makes my life easier, and it means that I'm not doing a bunch of itty-bitty calculations underneath the square root. It's already done. I can just plug it in. My life is much happier. Alright, b squared, which is negative 4 squared minus 4 times 2 times negative 3. Please be very, very, very careful of your sign. That way you do not have a bad day, because otherwise you will have a bad day. You will get some really, really weird numbers. Okay, negative 4 squared is 16, and then negative 4 times 2 is negative 8. Times negative 3 gives me positive 24. Add those together, I get 40. Alright, let's go ahead and start plugging this in. X equals negative 4. Again, please be very careful of your signs. Plus or minus the square root of 40, my discriminant that I already found up above, all over 2 times 2. There we go. Let's make this look a little bit prettier. Minus a negative 4 gives us positive 4, plus or minus the square root of 40, all over 4. Now that looks like a nice pretty answer. However, I do want to work on... Sorry, I'm back. The custodian kind of popped open my room all of a sudden. Let's go back to simplifying this. All right, I was just saying that this looks like a nice, pretty answer. However, I do want you to make sure that any radicals that you have, you please make sure you simplify them. Now, on a separate piece of paper, I went ahead and simplified the square root of 40. I saw that I was able to pull out a 2, and thus it will look like this. 4 plus or minus 2. Alright, sorry once again, I am just very popular today. Gotta love it. Okay, we were in the process of rewriting this. 4 plus or minus 2 times the square root of 10 all over 4. And when I do that, I see that I've got a 4, a 2, and a 4. And they all share a common factor of 2. Do not, pretty please and thank you, do not make the mistake I see a lot of people doing and trying to factor the 10 in any fashion. Do not touch it. It is in radical jail. It is in trouble. Please do not take it out of radical jail. When we factor the 2 out completely, we get 2 plus or minus, and that 2 goes away. We are left with the square root of 10 divided by 2. And there we're done. Now, if I wanted, I could put that in my calculator and I can get a decimal. Especially if you're on a test, please don't plug it into your calculator. Just leave it like that. I'm perfectly happy with that. If you put in your calculator, you are inevitably going to round because you're going to get a nice, long, nasty decimal. And I would rather have you give me this answer. That way, if I actually need it for something, then I can decide how much I want to round to, because my rounding may not be the same as your rounding. You don't get to pick for me how much I round, okay? Let us do another example here. Scroll down a little bit. Our next equation is 9x squared plus 12x plus 4 equals 0. So our numbers got a little bit bigger, but it's all cool. We can totally do this. Let's find the discriminant again. We have 12 squared minus 4 times 9 times 4. All right, 12 squared is 144 minus 4 times 9 is 36 times another 4 is 144. Gives me 0. Well, that's convenient. Let's go ahead and plug that back in. X equals negative 12 plus or minus the square root of 0, which was my discriminant, all over 2 times 9. All right, let's make it look pretty here. Negative 12 plus or minus, well, the square root of 0 is just 0. All right, let's just leave it as is, all over 18. Now remember that anything plus or minus 0 is just itself. We're really looking at negative 12 divided by 18, which when we simplify that down, we simplify our fraction, we should get negative 2 over 3. I would prefer the fraction on this one, really. I know that's so tempting to put it onto your calculator and have it spit out a decimal, but the decimal for that is not very good. It's 6's repeating, and I frankly just don't want to deal with that, and I don't think you should have to either. Just leave it as the fraction. It's less messy, and if I need to round it, I will. All right? Final example here. Final example. 3x squared plus 4x plus 2 equals 0. Let's find the discriminant. You guys should be able to do this without too much issue. 4 squared minus 4 times 3 times 2, which gives us 16 minus negative 4 times 3 is 12. Times 2 is negative 24. 16 minus 24 gives us negative 8. Oh, it's a negative number, which means that there's going to be no real solution. So let's see what that actually looks like in practice. We have x equals negative 4 plus or minus the square root of negative 8 all over 2 times 3. Okay. Now, we all know that we don't like negative numbers underneath our square roots. It's just not very pretty, and we've got something for that. If you remember the complex number I, whenever you have a negative number underneath a radical, you can go ahead and factor out what's called I, which is the square root of negative 1. Here's what that's going to look like, just in case you've forgotten. Negative 4 plus or minus I times the square root of 8, which makes it not negative anymore under there. It's very convenient. All over 6. Now, once again, I would like it if you made sure that all of your radicals were fully simplified. I do know that I can simplify that square root of 8 further. Let's see what that looks like. Negative 4 plus or minus 2 times I times the square root of 2, because I was able to factor out that 2 from this square root of 8, all over 6. I see 2's. Got negative 4, 2, and 6, which all share a common factor of 2. Let's go ahead and factor that out now. Got negative 2 plus or minus, we're just left with I times the square root of 2 over 3. And with that, we are done. That is our imaginary solution. Now, remember that because it's imaginary, we can't plot that. That number does not exist on our real plane. Remember that means that our graph is just floating out in space. It's never actually going to touch our x-axis. For completion's sake, we can use this solution in other algebra topics, but this is just so that we know exactly what it simplifies into. That's really the point of that. Alright, that was my notes and examples on solving quadratic equations using the quadratic formula. If you like what you see, please remember to like and subscribe. And if you like what you see especially, please go ahead and send me a message if you have any questions, comments, concerns, or if you want to see me do a video on something else and it just happens to not be on my channel. I will be more than happy to take your request under consideration. Remember, have an awesome day, and I hope to see you guys in the next video. Bye-bye.